Now we're going to spend some time talking about chemical equations. The first thing that you're probably asking yourself is, what is a chemical equation? Well, that is a representation that chemists use to describe a chemical reaction using chemical formulas. We've seen some of these before, such as the combustion reaction, when we were talking about combustion reactions and finding the empirical formula. So here let's take a look at a simple combustion reaction. Methane plus oxygen gives carbon dioxide and water. Well, we have to have two equivalents of oxygen to produce the carbon dioxide and the two equivalents of water that we have. So the first thing I want you to do is look at this equation and see that there's a couple things going on. We have a group of things on the left and a group of things on the right. And no matter what we have, the group of things on the left, the number of atoms has to equal the group of things on the right. We cannot neither create nor destroy matter. We can only change its form. So we have to make sure that we have the same number of carbons on the left and the same number of carbons on the right. Well, we can break the left and the right into two parts. We consider the left to be the reactant side, and we consider the right to be the product side. So you take your two reactants, you mix them together, you add heat or anything else that you have to do to get the reaction to go, and then you're going to get your products out. Now when we add heat to a reaction, it's okay. We don't really have to take that into account as a reactant because it's just an external stimulus that we put in. It's not changing anything other than allowing the reaction to occur. You'll notice though that with the chemical reactions, there's some little symbols next to the molecules. Those are going to be the states of matter. If we put a G in parentheses, that's going to signify a gas. An L in parentheses is a liquid. An S in parentheses is a solid. In a couple of days, we're going to be talking about a lot of solutions that we do in water, and those are given the symbol AQ. That means they're aqueous solutions, and that means the product has been dissolved in water. So we'll see that in a little bit, and we'll actually do a lot of calculations about those solutions later on, but for right now just realize that AQ is an aqueous solution. It's dissolved in water. It's not actually a state of matter. Once we set up an equation with the reactants on the left and the products on the right, we have to make sure we balance that equation. So let's take a look at S8 plus O2 goes to sulfur trioxide. The best thing that we can do is start with an atom on the left and make sure we balance that on the right. The best place to start here is going to be with sulfur. We know that if we have one S8 on the left, we can have 8 SO3s on the right. That means we have 8 sulfurs on the left and 8 sulfurs on the right. Since we now have 8 sulfurs on the left and we've balanced that with the sulfurs on the right, we need to look at what else is attached to the sulfur on the right. That's going to be 3 oxygens. Well, that's only if there's one. Now we have 8, so we have 8 times 3, which is going to be 24 oxygens on the right. To make sure that we have 24 oxygens on the left, we have to take the number of oxygens that we have and divide by 2, because we have a molecular form of oxygen. Each molecule of oxygen is going to contribute 2 oxygen atoms. So if we have 12 O2 molecules, we'll have 24 oxygens on the left. So in order to balance our equation, we have to have 1 S8 plus 12 O2s to give 8 SO3s. And while it might seem a little crazy the way I did it, this is going to be the way that works out best to balance your equations. So let's go ahead and try another example. Potassium plus Br2 goes to potassium bromide, KBr. Well, if I have one potassium on the left, I can have one potassium on the right. And if I have one potassium on the right, that means I'm going to have one bromine on the right. In order to have one bromine on the left, I have to have half of a Br2 because bromine is bimolecular. But there's a problem. We cannot have fractions in our equations when we balance them. So if I have a half fraction anywhere in my equation, I have to multiply by 2 in order to get rid of that reaction. I'm going to multiply the entire equation by 2 in order to get to the right product. So when I take 2 times 1 for the potassium, I'm going to get 2. When I take 1 half times 2, I'm going to get 1 for the Br2. And that means that I'm going to take and get 2 KBRs out for my product. And that's how you can go through and balance these equations in order to get a handle on making sure that you're balancing them correctly. I've provided an extensive list of practice problems in the Balancing Equations PDF file under the course document tabs of our Blackboard course site. So make sure you download that PDF file, print it out, and work those on a separate piece of paper. One of the things that I have also provided is a key, but that will become available in 2 days' time so that you can practice these before you come to class. We can do some more in class, and then you can practice these later on before the key is made available. Balancing chemical equations will be a very important part of the rest of the course. So if you have any questions about balancing equations, please bring these to class so we can discuss them.